combining integers. You might think of this more of as subtracting integers. I like to actually refer to it as combining integers because depending on how you visualize it, you might still be actually adding the numbers. So what do I mean by that? So you could see this as -9 minus 3, or I like to just kind of circle the number. I have -9, I have -3, I have 9 negative signs, 3 more negative signs. I have a total of 12 minus signs there. So that is a -12. I combined -9 and -3, or you could say I took 3 away from -9. However you like it, that is -12. So in a problem like number 2, if I'm circling the sign in front, there's nothing in front of the 6, but we are going to assume that's positive. We've been writing numbers for many years, and we never wrote a sign in front of them, but they were always interpreted as positive until now we've come to the integers. So then this is a -12, so we've got a +6 and a -12, so 6 of the positives cancel out with 6 of the negatives, but there's still 6 more negatives that survive. So for the most part, the problems on this page should be straightforward. Either we've got positive and negative, or we've got 2 negatives together. But let's keep moving on to some more challenging examples below. So on this worksheet is where we start to see some double signs taking place. So a problem like number 5 here, we see 8 minus a -3. And if we apply the logic that we did in the many meanings of minus, we can think about what to do with a double negative. We're taking away something bad. Well, that's good. So we could rewrite this as adding something good. So 8 minus -3 is the same as 8 plus 3, or 11. You could also think that this kind of combines with theirs. We've got one line, they kind of form a plus sign. However you want to do it, minus a negative is the same as adding. So we saw that with a positive minus a negative. Well, what happens if we have a negative minus a negative? Well, the first negative is not part of the problem here. It's really the double negative next to each other that we want to resolve. So we still have the -4, but the minus a negative turns into a plus 8. Okay, so now we think 4 negatives, 8 positives, they cancel. We have 4 positives remaining. Great. So that should apply to most of these problems and help you to solve the rest. The numbers get a little bit bigger, but otherwise not too much different, until we come to problems like number 31. Now in problem 31, we've got lots of double signs. So I would definitely start by rewriting the whole thing to get rid of any double signs. So 43 minus a -53 is plus 53, minus a -26 is plus 26, and now we've got an old school addition problem. 43 plus 53 is 96. 96 plus 26, 102, 122, is our final answer. Great. So definitely, I always recommend getting rid of any double signs first, and then you can circle the sign in front if you need, and you can evaluate that way. We continue. We add even 4 at a time here. But our same rules should be able to apply to get us through all of these examples. And then we have some more fun with a couple new cases happening here. All right, so here it just looks a little bit different, but we did actually cover this in the last one. We've got -11 minus a -16. This is still a double sign here. We've got a minus here and a negative there. So we can rewrite this as -11 plus 16. So we do some canceling. We know we have 5 positive left over at the end. Number 24, a little bit different. We have to take the absolute value of -82. That, of course, gives us 82. And then we can resolve our double sign to make that a plus 6. Oh, 82 plus 6, 88. Excellent. Whoa, number 46. We've got a triple minus sign happening here. So you've got a whole bunch of different ways you could approach it. You could combine these two and make that into a plus, and then know that you're going to be adding a -94. You could, instead of that, choose to combine these negatives. So the opposite of -94 is 94, and then you have to take 73 minus 94. But ultimately, what you need to think about is we've got 3 minus signs. Any 2 of them can turn into a plus sign, but it's going to leave the third one alone. The third one will not get changed. So let's go ahead and rewrite 73. We could do plus -94. Now, if you want to here, you could resolve these 2 signs. Adding something negative is the same as taking something away, so we could rewrite this now as 73 minus 94 if you like. At the same time, you could recognize 73 positives, 94 negatives, and you could just figure out how many cancel out and realize that you're going to have 21 more negatives at the end of the day. Let's look for any other tricky examples out there. 48 is a little bit tricky, but we've really dealt with problems of that difficulty. But once again, let's work inside the parentheses. Negative 73 minus 1, so that's going to be negative 74. And we've still got the negative outside, so the opposite of negative 74 is positive 74. So with that, we should be able to handle all of these other examples on these pages, and this page, and this page. Lots of practice. This is one of those things that definitely more practice will help you become more fluent at this skill. All right, so what is the meaning of an absolute value? We've talked about this a couple times, but there's a little bit of a review. The meaning of the absolute value is the distance from 0. Now it does make whatever's inside positive, but we do have to think about any signs outside that can change that. All right, this you definitely have to go back and look up. If you don't remember the 3 meanings of this symbol, which I will not name because it may have 3 different names, definitely go back and watch the many meanings of minus to finish that out. Okay, circle any of the following which are not integers. Definitely want to make sure we're clear on this. So integers are positive and negative whole numbers. So 2/3 is a fraction. It can't be written as a whole number. So that is not an integer. 1.45 is not an integer. It's got a decimal. So decimals and fractions don't count. Now, if I said 6/3, should we circle that number? No, that is an integer. 6/3 is 2. So it could be simplified to an integer. So it is an integer. So we don't want to confuse those as well. Okay. A little bit straightforward, maybe a little simple, but a thermometer currently reads negative 9 degrees Fahrenheit. If the temperature outside becomes 5 degrees colder, what temperature will it be? So I'm going to actually show what we would model this as. We are at negative 9, and we're getting 5 degrees colder, so we're taking 5 degrees away, so we're now at negative 14. You might have saw this as negative 9 plus negative 5. Maybe you're adding something cold like ice to something that's going to shrink the temperature. That way we would also get negative 14 as well. If a thermostat currently read negative 7 degrees Fahrenheit, and the temperature outside became 13 degrees warmer, well, that would be negative 7, and we're adding 13 to that. So what would the temperature now be? The temperature would now be 6 degrees Fahrenheit. So again, a little bit more application to that. All right, I definitely want to give you a crack at this one first. When you add a negative integer to a positive integer, how do you know if your answer will be positive or negative? You definitely want to try to use the term absolute value in explaining your answer. That's going to give you the most clear and detailed explanation that covers all your bases. Definitely something we should talk about in class after you've given a shot at trying to show how that works. All right, see you next time.